Today we're going to dive deep into the world of exponent simplification. This is a fundamental skill that you'll use throughout algebra and beyond. We'll break everything down step by step so you can master these concepts with confidence. Before we jump into complex problems, let's review the essential properties of exponents. These basic rules form the foundation for everything we'll do today. Understanding these principles will make all the advanced problems much easier to solve. So let's start with the fundamental concepts and build from there. Let's begin with our first example. What happens when we multiply x to the sixth power by x to the third power? Can you figure out what this equals? When you're multiplying terms that have the same base, there's a specific rule you must follow. You need to add the exponents together. So 6 plus 3 gives us 9. The result is x to the ninth power. But why does this work? Think about what exponents actually represent. X to the sixth means we're multiplying 6x variables together. X to the third means we're multiplying 3x variables together. When we multiply these expressions, we're combining all those x variables. That gives us a total of 9x variables multiplied together. This is exactly why the answer is x to the ninth power. Now let's explore what happens with division of exponents. Consider this problem. What is x to the 10th power divided by x to the 6th power? When you're dividing terms with the same base, what operation should you perform on the exponents? The answer is subtraction. We subtract the bottom exponent from the top exponent. 10 minus 6 equals 4. So our answer is x to the 4th power. Let me explain why this makes sense. X to the 10th power represents 10x variables multiplied together. X to the 6th power represents 6x variables multiplied together. When we divide, we can cancel out 6x variables from both the numerator and denominator. This leaves us with 4x variables remaining in the numerator. That's exactly why we get x to the 4th power. Here's another important concept to master. What happens when we raise x to the 5th power to the 2nd power? This is called raising a power to a power. In situations like this, you need to multiply the exponents. 5 times 2 equals 10. So x to the 5th raised to the 2nd power equals x to the 10th power. Let's think about why this rule works. X to the 5th raised to the 2nd power means we're multiplying two groups of x to the 5th. Each x to the 5th represents 5x variables multiplied together. When we have two groups of 5x variables each, that's a total of 10x variables. Therefore, our final answer is x to the 10th power. Now let's discuss a special case that often confuses students. What is x raised to the 0 power? What do you think this equals? Here's the important rule to remember. Anything raised to the 0 power equals 1. So x to the 0 power equals 1. Similarly, 7 to the 0 power equals 1. This might seem strange at first, but it's a fundamental property of exponents that you'll need to memorize. Let's tackle negative exponents, which can be tricky for many students. What happens when we have x raised to the negative 2 power? When you encounter a negative exponent, here's what you do. Take the variable and move it to the denominator of a fraction. When you do this, the negative exponent becomes positive. So x to the negative 2 becomes 1 over x to the positive 2, or 1 over x squared. The same principle works in reverse. If you have 1 divided by x to the negative 5, you can move the x variable to the numerator. The exponent changes from negative 5 to positive 5. So the result is x to the 5th power over 1, which simplifies to just x to the 5th power. Here's a crucial distinction that trips up many students. Pay close attention to this example. What's the difference between negative 2 squared and negative 2 squared in parentheses? These look similar but give completely different answers. Negative 2 squared without parentheses means we have a negative sign in front of 2 squared. The exponent only applies to the 2, not the negative sign. So we get negative 1 times 2, which equals negative 4. However, negative 2 squared with parentheses means the entire negative 2 is being squared. Negative 2 times negative 2 equals positive 4. Remember, parentheses make all the difference in problems like this. Let's practice with some problems that combine these rules. Try to simplify this expression x to the 2nd power multiplied by x to the negative 6th power. Remember, when multiplying with the same base, we add the exponents. 2 plus -6 equals -4. So we get x to the -4 power. Since we have a negative exponent, we need to rewrite this as 1 over x to the 4th power. This is our final answer for this problem. Here's another practice problem for you. Simplify x to the 4th power raised to the -3 power. When raising a power to another power, we multiply the exponents. For times -3 equals -12. So we get x to the -12 power. Since this is a negative exponent, we rewrite it as 1 over x to the 12th power. This process of converting negative exponents to positive ones in the denominator is essential to master. Let's try a division problem now. Simplify x to the 5th power divided by x to the 9th power. When dividing with the same base, we subtract the exponents. 5 minus 9 equals -4. This gives us x to the -4 power, which we rewrite as 1 over x to the 4th power. You can also think of this conceptually. We have 5x variables in the numerator and 9 in the denominator. After canceling 5 from each, we're left with 4x variables in the denominator only. Now let's work with expressions that have coefficients and multiple variables. What is the value of 2x cubed raised to the 4th power? We need to apply the exponent to every part of the expression. 2 raised to the 4th power times x cubed raised to the 4th power. 2 to the 4th equals 16. For the x term, we multiply the exponents. 3 times 4 equals 12. So our final answer is 16x to the 12th power. Let's try a more complex example. Simplify -3x squared y to the 5th raised to the 3rd power. We apply the outer exponent to each factor inside. -3 to the 3rd power times x squared raised to the 3rd power times y to the 5th raised to the 3rd power. -3 cubed equals -27. X squared raised to the 3rd power equals x to the 6th power. Y to the 5th raised to the 3rd power equals y to the 15th power. Our final answer is -27x to the 6th y to the 15th. Here's a multiplication problem with multiple variables. Simplify 3x to the 5th times 6x squared. First, multiply the coefficients. 3 times 6 equals 18. Then multiply the x terms by adding exponents. 5 plus 2 equals 7. The final answer is 18x to the 7th power. Let's try another multiplication problem. Simplify 2x cubed y squared times 5x to the -2nd y to the 4th. First, multiply coefficients. 2 times 5 equals 10. 4x terms. 3 plus -2 equals 1. So we get x to the 1st power. For y terms, 2 plus 4 equals 6. So we get y to the 6th power. The result is 10x y to the 6th power. Now for some special cases with the 0 exponent. What is -3x squared y raised to the 0 power? Remember, anything raised to the 0 power equals 1. So this entire expression equals 1. But what about -5x to the 0 power? Here, only the x is raised to the 0 power, not the entire expression. So x to the 0 equals 1, and we're left with -5 times 1, which is -5. Let's tackle a division problem with multiple terms. Simplify 18x to the 9th y squared divided by 6x to the 5th y to the -8. First, divide coefficients. 18 divided by 6 equals 3. 4x terms. 9 minus 5 equals 4, so we get x to the 4th. For y terms, 2 minus -8 equals 2 plus 8 equals 10, so we get y to the 10th. The final answer is 3x to the 4th y to the 10th. Here's our final complex example. Simplify 20x squared y to the 6th divided by 40x to the -3 y to the 4th, all raised to the 2nd power. We can simplify inside the parentheses first. 20 divided by 40 equals 1/2. X squared divided by x to the -3. 2 minus -3 equals 5, so x to the 5th. Y to the 6th divided by y to the 4th. 6 minus 4 equals 2, so y squared. Now we have 1/2 x to the 5th y squared, all raised to the 2nd power. Applying the exponent, 1/2 squared equals 1/4. X to the 5th squared equals x to the 10th. Y squared squared equals y to the 4th. The final answer is 1/4 x to the 10th y to the 4th.